Hello, today we are going to take a look at those two really interesting emergency lamps, and afterwards we are going to fix one of them and replace the cells. Let's take a look what this device actually is and what is the use case. This is an emergency light that you plug into AC power. And when this device is plugged in, it's going to constantly recharge the battery in that lantern, but it's not going to emit light at its basic functionality. And if the power is going to be disrupted, the lamp is going to automatically turn on and give you an emergency light. The good question would be, why do you need an emergency light? Just imagine that you've got a public accessible building, that you've got random people who don't know the layout of the building, and maybe there is a power outage or a fire, and the fire brigade is arrived and they want to put a water on top of the building, and they are disabling the AC input to the building, and everything turned black and you cannot see anything. So to avoid panic and let people guide how to safely escape, you've got emergency lighting that is battery operated, and it is completely not tied to the grid and can work without a AC power supply. And of course they are also using a safe voltage, so water is absolutely not a problem. You are not facing any risk of electrocuting anyone. In general, if you are in your own home, then you most likely can blindfold yourself and do a small experiment, and you will be able to get out and go straight into the door because you know the layout. In other buildings, that's not the case. You might be a first time, and this is a very helpful device, and I believe they are mandatory. Mostly I've seen emergency light that are built into light fixture, so they looks like just a regular ceiling lamp, but they've got additional diodes and built-in battery. So if the primary AC power supply will be down, the backup LED is going to be lit. But this is a great device because, as you can see, it's designed to be mounted on the wall, and it gives you the same operation, but you can grab this unit and you can take it and use just like a regular flashlight. Let's take a look how this device is working. That one I've got plugged into AC. We've got a LED glowing. I can hear a sound from a transformer. The lamp is not being lit, and that's the ideal condition. But just take a look what's going to happen when I'm going to remove the AC power. And the lamp turns itself on. The power LED is not glowing anymore, and you can go and find this unit, and you've got a flashlight. So it is an absolutely great device. I love it. It has extremely positive feeling when you are mounting it. That's because it's being held in place by those magnets. That looks terrible. Here is another set. You really got an Apple feeling when you are docking it. Just take a look at this. It just snaps into place to make a good contact, and no worries, it's not going to go anywhere. Let's see, this is the model number. We've got a nice grommet on bottom and another marking from the manufacturer. Let's take a look at them. That part is extremely rugged, built out of metal, very heavy, very good. I like the design. They just use a piece of PCB, very nice, cost-effective measure. Let's see what's inside. Screw have like a waterproof seal. Very nice design. I'm not sure what kind of IP rating they are trying to get, but it's nice. Look at the attention to details. We can see the main AC going into, and on the bottom, on the back, you can see just a regular transformer. Since we've got the positive and the negative, I assume somewhere in between there will be a diode that's going to rectify that voltage. But yes, nothing else. Extremely simple construction. I just grabbed the broken one because we are going to fix it. So this is how it looks like. As you can see, it's looking just like a standard torch. First thing that is really interesting is this power switch, because it feels like an extremely cheap tactile switch. But if you take a look, we've got two switches, and I believe they know that one of them might fail. So you've got a backup one, and they are in parallel, and they are doing exactly the same thing. Here we've got the model number. The contacts that are mating with the docking station. Here is where the current is actually flowing. Those are magnets that are only held it in place. And I saw a replacement on the AliExpress. I'm just going to measure them and find a replacement, because the chrome plating looks like it's being eaten away. This is old stuff. Here you can see that we've got a lot of LEDs, and that's a great choice, because if any of them fail, the light will be still operational, in compared to getting like a Cree LED and the PWM driver. Here you can see the build quality. What's the best is they properly seal all the cables, so any shock and vibration is not going to be affecting. And on the small controller board, they also do the same. They put that glue GUI, and not much. So yeah, if you take a look at the base station, extremely rugged, solid metal, and this part looks flimsy, looks extremely cheap, especially if you compare to like a Streamlight Duty Firefighter's flashlight. It looks like a joke. And to be honest, I was thinking about that they spend so much money on this and so less on that flashlight itself. And I believe that was by design. So we've got like a fire emergency, people are evacuating, they are going to grab this and take into the field, and most likely many of them is not going to be returned. So I believe this is like a single use. So if that get lost, you just reorder that part and put it back. I believe that's the only reason why this is so cheaply made. Let's replace the cells. The process is very simple. We are just going to unscrew those two terminals. And it will lose the battery pack inside. The ingress protection on that part, it not looks really good. The only thing good is that they use a machine screw, so you can do that many times. And now our battery pack is going to be free. And if you take a look, this is the battery pack. We've got a 4.8 volts in form of 4 AA batteries connected in series in that very nice holder, very nicely built. You can fit a much bigger battery. That the room looks exactly like a small SLA 6-volt battery. So maybe they switch from SLA and regular bulb into the LED. And here is our battery pack. So we have to make ourselves a new one. Those are my another great findings. The nickel metal hydride from IKEA. Very good low price in compared to the capacity. They are cheaper than the Eneloop blacks. But for low power applications, that's a 100% way to go. Let's to arrange them. In something like this. This is time to put safety glasses, and we are going to make couple spot welds. Very nicely. So as you can see, we've got a really nice battery pack, 4.8 volts. We've got the positive, the negative, and they are connected in series. And we can connect them to the flashlight. Okay, looks beautiful. Now the terminals. Let's stripe them. That's a beautiful job. That one is going to be the negative. Let's grab our positive terminal. The light should be operational. And yes, it is. Let's secure. And now we can reverse the order. You can't mount this wrong because there is only one way that the screw are going to fit. So it is a idiot proof. Here is a smaller gap. And let's connect it. Quick power check. Yes, it does work. Will it recharge? We've got a power LED. Drop it in place. Let's kill the power. And it go into the backup mode. So as you can see, with those couple simple steps, we were able to fix this light and give it another 10 years of use. So thank you very much for watching. I hope you find it interesting. See you next time and bye bye.